Alright, welcome back. So, we're on 2016 FRQ this time. So we'll be looking at parametric equations. Specifically, finding position, slope, and speed, distance traveled of a particle given parametric equations of its velocity and position. So starting here, we've got a parametric equation for the horizontal velocity in terms of time given here in dx over dt. And I've got a graph of the vertical position in terms of time given here in yt. I want to find the position of the particle at t equals 3. What do I have to do?
We integrate dx
Okay, I can integrate
over
dx.
dt.
If I integrate dx, that's going to give me my change in position of x. What else will I need?
And plus 5.
Okay, plus 5. So that's my starting position plus my change in position. Should give you my position at that time. So if I want position at 3, this is x at 3 is equal to, you said 5 plus the integral of our change. So that's 5 plus the integral from what to what?
0 to 3 and dx over dt.
Okay. All right. And then what about y at 3?
Oh, it's just graph of the, point of the graph. Just graph.
Okay, you're right. So this is just the y value of the graph.
Yeah, y value of the graph. Which is minus 0.5.
Okay. So we'll go ahead and integrate. This is I'm going to throw this in here just in case we need it later. So this is x squared plus the sine of 3x squared. We're integrating from 0 to 3. Okay. So I've got x position and y position. Well, let's put them together and we've got our position. What do we do for b?
Slope, so that's dx over dy over dx.
We need to be a little bit more specific.
Y over dt over dx over dt.
Okay. So we could say dy over dx is dy over dt divided by dx over dt is, we're doing this at 3. So y prime at 3 over x prime at 3. Okay, what's the derivative of y at 3?
2, 1, so that's my 1/2.
Okay, positive 1/2. And then x prime at 3, we're going to plug 3 into this equation.
So, yeah, just plug in.
Okay, so I've got 9.956.
Mm-hmm.
So half divided by that is roughly 0.05. So what does this actually represent?
The slope.
Okay, so this is the slope of the tangent line. But what does that mean in terms of the particle?
So at t equals 3, d dx and dy, x and y increases by 0.04.
Close. So whenever y increases by 0.05, x should be increasing by 1, right? This is the slope of the tangent line is the slope of the arc of the curve. So if you're going to take a 2D picture of what's happening to your
Mm-hmm.
height and horizontal distance from the start point, your slope of that arc is what we just found.
Yep.
Okay. How do I find the speed of the particle?
So that's square root dx over dt square and plus dy over dt square.
Okay, perfect. So that's really dl over dt squared equals dx over dt squared plus dy over dt squared. And then we've solved for dl over dt, which would give us the change in the length of the arc over time, which gives us speed.
Mm-hmm.
And we're doing this at 3. We've actually already solved for these values, so we can just plug that in directly, I think. So speed is the square root of... So this was 9.956 from the last slide. And we said this one was 1/2. Okay, so this is our horizontal velocity at 3 squared, plus our vertical velocity at 3 squared, and then underneath the square root gives us 9.969. Okay, and then total distance traveled.
That's integration from 0 to 2 square root dx over dt square plus dy over dt square.
Cool. So we're taking our speed equation that we had last time and just integrating that to get our total distance traveled.
Yep.
Okay, and this time going from 0 to 2. So this is... Okay, I've actually got a problem here. Because we've got a piecewise function for our dy over dt, right? So I need to split this up. What do I need to split this up into?
Square integration from 0 to 2 1 plus dy over dx square.
So my problem is my function for dy over dt is different based on what my x value is. So I can't integrate this as one function. I'm gonna have to break this apart. Where do I need to break this apart?
Oh, integration from 0 to 2 dy over dx plus split it? How?
What's my dy over dt at 0.5?
0.5. I don't get it.
Okay, I'm gonna try to walk you through it. So forget the integral for a second. If you wanted to know the slope of y at 0.5, what would it be?
Slope of at 0.5, that's minus 2.
Minus 2. What about 1.5?
1.50.
Okay, that's a problem because our dy over dt is really a piecewise function where we just jumped from -2 to 0, right? So if we're integrating from 0 to 2, because we're dealing with a piecewise function for dy over dt, I can't integrate that entire interval as one integral.
Oh, so you mean we have to split the interval?
Right. I need to split the interval.
Oh, okay then. Square root from 0 to 1.
That's it. Okay. Dx over dt is a continuous function, so we can leave that as is. But you told me dy over dt from 0 to 1 would be -2, so I've got to leave that.
Yep.
A constant. Okay, and then what am I going to add?
Plus
1 to 2.
Okay, the integral from 1 to 2 of...
Square root dx over dt. And 0 square.
Okay. So we can throw all that in. put one too many parentheses in here somehow. Okay. I am integrating. Oh. Y1 squared plus 4 underneath the square root. In terms of x from 0 to 1. And y1 squared plus 0. It's really just y1 I should have written, but that'll work as well. Okay, so I've got the integral of y1 squared plus 4 underneath the square root, which is this one, plus the from 0 to 1, plus the integral of y1 squared plus 0 underneath the square root from 1 to 2. Which gives us 4.35. All right. Any questions on what we did?
Nope.
Okay. So the homework for today is going to be question 1 and 3 from the same year. So that's 2016, which I'll post to the WeChat.